Hi guys, Mr. N. Moving on, Unit 5, solving inequalities. Let's do some problems. Let's get better. And this is from your manual. You should probably, you have probably solved it. But anyway, let's go over one more time. Different signs, different solution sets. Okay, now we cannot click on my page here, but let's see how should we solve each one of these possibilities. As you can see, the first one is an equation, the second one inequality, third one inequality. The signs differ, right? Well, first one, simple equation. All you need to do is add 5 to both sides because you took 5 away, and to find x you will put it back, right? What do we have? Well, you go column by column. You have x right on the left side of the equal sign, minus 5 plus 5, nothing. Bring down the equal sign, equals 9 plus 5, 14. You have to graph it. You go on the number line. Let's have blue for that, right? And you're going to draw a full circle here because that's what your x equals 14 is, right? And that's how you graph an equation. You use a full dot for it. Inequality, second one. X minus 5 less than 9. You solve it the same way by adding 5 to both sides. No differences, right? You add, you have x less than 14. Now, as you notice in here, to have x less than 14, you know that x cannot be 14. So on your number line, instead of that full dot that we have for x equals 14, and I can put it here, x equals 14. Here you have x less than 14, and I should use a different color here. X less than 14. And because it's less, because you have any number that's less than 14, you will graph it, with a line that points to the left, where your negative infinity is, right? On the right we have positive infinity. Moving on, let's try the other one. X minus 5 greater than or equal to 9. You add 5 to both sides. Same story, add each column. You have x greater than or equal to 14. Now for this one, you will definitely have x that would be greater than 14, but also your x could be 14, and that tells you should have a full circle here, closed dot, whichever way you want to call it, and anything that's greater than that. So anything from 14 to positive infinity. And these are the three possibilities of solving and graphing each one of these equation and inequalities. Okay, I hope it makes sense. Let's do another one. The sum of two consecutive integers is greater than 105. Find the least pair of integers. Okay. Now, first of all, let's remember first what is sum. Sum means what? When you add your numbers. Sum of two. So obviously you have one number and you have a second one. But more than that, they're telling you there are consecutive integers. Okay. And as in problems with missing quantities, you need to choose a variable for the one. And let x be the first integer, right? If x is your first integer, the second integer, because will be a consecutive one, and let me give you an example of consecutive integers. Negative 1, 0, 1, 2, 3, and 4. What do you notice? To move from 1 to the next one, I'm always adding 1, right? From negative 1 to 0, I'm adding 1. 0 to 1, I'm adding 1. 1 to 2, I will add 1. And now, if your integer is x, the next consecutive integer is 1. What do we need to do? We need to add 1. So it will be x plus 1. Okay? So here you have it, and you have your two integers, your two consecutive integers, right? X and x plus 1. The problem is telling you that their sum is greater than, and the sign for greater than, we know it, right? 1 of 5. Well, let's write it as an inequality. And I have x plus 1, right? You can put it in parentheses just to show that this is the second integer, is greater than or equal to 1 of 5. Now, to solve this inequality, you need to remove that parenthesis, right? Which will give you x plus 1. And hopefully my tablet here allows me to do that, right? X plus 1 greater than or equal to 1 of 5. You will combine the two x's, that gives you 2x plus 1 greater than or equal to 1 of 5. To solve, you will take 1 away from both sides. Okay? On the left side of the inequality, you have 2x, 1 minus 1 is 0, greater than or equal to 104. Let's take it here, 2x greater than or equal to 104. To find your x, you will divide by 2. 2 divided by 2 is 1. X should be greater than or equal to 104 divided by 2 is what? 2 goes in 10. 5 times. 2 goes in 4. 2 times. And now you find that your x, your first integer, has to be greater than or equal to 52. So my question is, can that x be 52? Yes, it can, right? So x could be 52, 53, and so on. But the problem is asking me to find the least pair. So I need to find the least, the smallest x, and that would be 52. It cannot be less than that. And if my x is 52, my x plus 1 would be 53. And this is the answer to your problem, okay? The pair of integers here would be 52 and 53, okay? If you add them up, that should give you 105. Is that so? I think so. Good. Let's do another one. The sum, same problem, you add, of two consecutive integers is at least, right, 135. Find the least possible pair. So we're going to solve this problem the same like in the previous one. You have your x, first integer, x plus 1 will be the next one. Their sum, x plus 1, should be at least. At least. Think about it. Can be less than that? If it's at least 135, it cannot be less than that. So I'm looking for x plus 1 greater than or equal to 135. I mean, if we're going back to the previous problem, is greater than, right? Well, at least seems to be the same thing, right? At least 135. Can be 136, can be 137, but must be at least 135. No less than that. Combining your like terms, 2x plus 1 greater than or equal to 135. It seems to be solved exactly the same way. You take 1 away, like in the previous problem, right? You have 2x should be greater than or equal to 135 minus 1, 134. To find your x, you will divide each one by 2. X should be greater than or equal to 134 divided by 2 will be what? 2 goes in 13. 6 times 2 goes in 14, 67, right? You need to find the least possible pair. And looking at your x, which is your first integer, right? That could be equal to 67 or greater. So 67 is the least one. Obviously your next number will be 68, and we are done. If you add them up, that should give you 135, and that's the case. Good. This is the way you solve a problem like this. Okay? Let's try another one. Alright, simple inequality here, m over 6 minus 2 less than 2. To solve it, you will add 2 to both sides, right? Because you want to have the expression with them by itself. M is your variable. If you add, minus 2 plus 2 will cancel out. You have m over 6 less than 4, right? Because 2 plus 2 is 4. Next step, you want to find m. You will multiply both sides by 6, right? Because 6 and 6 here will give you 1. You will have m less than 4 times 6, 24. And you are done. If you need to plot this one on the number line, right, you will have your number line. You will have the positive infinity, you will have the negative infinity, and somewhere here will be your 24. Because the equal sign is missing, because your m cannot be 24, you will have an empty circle, right? And let's use a different color for you. Empty, okay? And it has to go which way? M is less than 24. Less than 24 will go all the way to negative infinity, and eventually my tablet will show that, okay? And this is how you solve, this is how you graph. Moving on. How about this one? U minus parentheses 2 plus 3u, close the parentheses, greater than or equal to u over negative 3. Alright? What should be done first thing? Well, if you think about order of operations, you have a parenthesis, but as you guys notice in here, this parenthesis could be removed by just applying that negative sign to everything inside the parenthesis. So everything there will change its sign because you're basically adding their opposite. So it will be u minus 2 minus 3u. That negative sign is like multiplying negative 1 to everything inside the parenthesis. Greater than or equal to u over negative 3. Next step, you can definitely combine the like terms on the left, which gives you u minus 3u will be negative 2u minus 2 greater than or equal to u over negative 3. What should we do next? I have u over, a negative 3. I can multiply everything by negative 3, and that will remove my denominator on the right side. So I have negative 3 times negative 2u, which will make positive 6u. Then I have negative 3 times negative 2, which will make a positive 6. Now be careful, because you're multiplying a negative number, your inequality sign switches, right? We talked about this in class, why this thing happened. Negative 3 times negative 3, times u over negative 3 will be just u, right? You see that? Negative 3 times u over negative 3, you have negative 3 and negative 3 that will cancel out, and you're only left with u. Okay? Next step. Well, I want to take the 6 away from my 6u. Take 6 away, subtract 6, or actually, I should put it, subtract 6, and then because I want to have my u on the left side, I'm going to take u away from both sides, okay? As you can see, I'm doing 2 steps in one line here. 6u minus u will be 5u, 6 minus 6 is nothing, greater than or equal to u minus u is nothing, negative 6. Final step, you will divide by 5. 5 divided by 5 is 1 u will be greater than or equal to negative 6 over 5 will be what? 1.2. Okay? And this is the answer if you have to graph it. You will have your number line, right? On your number line, you have your negative direction with negative infinity, positive infinity. Let's say I have my negative 1.2 here, because u should be greater than or equal to that. Will be a full circle, right? And everything that's greater than that, all the way to positive infinity. Okay, that's the way you graph it. Alright, let's see a few more. 0.125 greater than 3 over 8q. Okay, now first thing I need to mention here is that q has to be different than 0. Alright, next step. To find my q, I will, and I'm able to multiply by 8q on both sides, because now I know my 8q is not, cannot be 0. I'm trying to remove my 8q from the denominator part, right? And I have 8q times 0.125 on the left side of inequality. Inequality stays the same because 8q doesn't have any sign, right? Has a positive sign, when I say. And I have 3 over 8q times 8q. Well, 8q and 8q are cancelling out. I have 8q times 0.25, which gives me what? I have 8 times 0.125, that is 1. 8 times 5, 40. 8 times 2, 16 plus 4, 20, right? 8 times 1 is 8 plus 2, 1. So basically I'll have 1.0 times q, which is just q, greater than 3. And we are done. Now let's get back to the restriction that we mentioned at the beginning. Is my q different than 0? Well, definitely it is, right? Because q is greater than 3, so that multiplication, basically having q as a denominator, it was okay, because my q, the solutions for this inequality, are all the numbers that are greater than 3. Can they be 3? Can that q be 3? I don't think so, right? Because it's greater than 3. This is my 3 on the number line. Eventually my tablet will allow us to move on, right? I will have an empty circle, right? And will be everything that's greater than that, all the way to positive infinity. Great, let's do another problem. The sum of two consecutive even integers. Now this is a similar problem with the previous one, but there is one thing that we did not have in the previous one. It's talking about even integers, right? Is no greater than 1249. We know the sum is plus two consecutive even integers. Now you can again, use x for the first even, right? First even integer. And obviously the next one will be x plus 1. Okay, we're going ahead, and we know that their sum is x plus 1 is no greater, okay, which means it can be that, but has to be less than, right? So less than or equal to 1249 is no greater. Can be greater than 1249? No, it cannot. Combining your like terms, right? You have 2x plus 1 less than or equal to 1249. But I made a mistake. Where is my mistake? Can you guys tell me? Let's get back to the problem. What is my mistake? If x is the first integer, the first even integer, the next even integer will not be x plus 1, right? Because we have what? 2, 4, 6. The next even integer, you need to add 2, right? You guys agree with me? From 2 to 4, I need to add 2. I need to add 2. So your x plus 1 is going to be x plus 2, actually, the next even integer. So let's fix that. 1249. Right, combining like terms, I have 2x plus 2 less than or equal to 1249. I'm taking 2 away from both sides because I want to solve for x, right? I got 2x, 2 minus 2, 0, less than or equal to 1249 minus 2 will be 1247, okay? I'm dividing by 2, both sides. What do we get? Well, 2 divided by 2 is 1. X should be less than or equal to 2 goes in 12 6 times, 2 goes in 4 2 times, 2 goes in 6 3 times. You need a decimal, right? 2 goes in 1 or in 10, you may say 5 times, you have 0.5. So your x has to be less than or equal to 623.5, but I know x is what? X is even, and I'm looking for the greatest pair. So what is the greatest value of my x? Right, if you said 622, right, you were right, but looking at it, right, if I need to find my x plus 2, that would be 624, so it's not going to work. So obviously I can either say that this is my x plus 2, or I may say my x has to be 620 and my x plus 2 would be 622. Okay, now if you add them up, what do you get? Well, 1000, well, you know, go right to left, 2 4 12, right, 1242, and this is less than 1249. Okay, is that less than 1249? I think so. Well, you know what, I'm thinking that I actually made a mistake, because we can go with 622 as being x. Hold on, let's erase some of the last part here, because indeed this one could be x, and 624 could be x plus 2, because if you add them, you'll still get less than 1246, or 1246, which is less than 1249. So be careful, right? Don't make the mistake that I made here. X has to be less than 623.5. It can be 622. X plus 2, the next consecutive integers could be 624, and here we are. This is you know, the answer to this problem. Okay, one more for today. The sum of a whole number plus half of the whole number is less than 0.75. Well, let's see how to solve this one. Okay, eventually we'll be able to write in here, right? Whole number. You guys remember the whole number set, we're talking about what? 0, 1, 2, 3, 4, 5, 6, and so on. Okay? And we're looking for a whole number. And let x be a whole number. Okay? What it says? The sum of x plus half of x, right? So you have x over 2, and let's write it down. The sum of x, so I have x plus half of it, is less than 0.75. Should be less than 0.75. Well, x plus 2 gives you what? To add them up, you need to change this x into a fraction, which will be 2x over 2, right? I have 2x plus x over 2, which will give me 3x over 2, less than, and if you want, you can even write at 0.75 as well. 3/4, right? To solve, I need to remove the denominators. I can multiply both sides by 4, okay? Which gives me 4 times 3x over 2. Alright, let's write it down. Less than 4 times 3 over 4. Now on the left side, 2 goes in 4, 2 times your cross cancellation, you have 2 times 3 gives you 6x, should be less than 4 and 4 cancelling out, less than 3, right? Dividing by 6, you have x should be less than 1/2. Alright? So I'm looking for a whole number that is less than 1/2 as the answer to my first question or first task, right? Find the greatest valid whole number that will satisfy this statement that the sum of that whole number and the half of it would be less than 0.75. Well, what whole number is less than 1/2? What do you guys think? The only whole number left less than that would be 0. Okay? So your answer here will be 0. And that's the answer for A. Now B says, how would your answer change if the number was a natural number instead of a whole number? You guys remember that, the natural number set. Remember when I told you that natural numbers are basically the numbers that you learn as a baby, right? 1, 2, 3, 4, 5, and so on, right? Going on to infinity. The whole number set still got the end, but it's got the sign that is telling you, I'm sorry, hold on, it's backwards, right? Actually, the natural numbers will have the sign, the asterisk over there telling you that 0 is missing. So that's the natural numbers, and the whole numbers will be n, but 0 will be included here. Okay? And you'll go all the way. So the only difference between the natural numbers and the whole numbers is the element 0, right? The number 0, which is not present in the natural number set. Remember when I told you the story that we don't teach our babies 0. When the little kids are learning to count out, up to 10, they learn as 1, 2, 3, 4, 5, and so on, right? Nobody tells them about 0 and stuff. Yeah, so if you have to answer the last part of your problem, how it change, you will say that for that problem, for that part, for this one, there will be no solutions. Because if your number has to be less than 1/2, there is no natural number less than 1/2. Okay? And that's how you have to solve a problem like this. Thank you. I'll see you soon.